Hello, IK here. Welcome to How Machine Learning Works, Part 3. Firms OpenAI installs massive content on Azure servers. After that, OpenAI AI company installs tokens, numbers, vocabulary. And tokenizer. Tokenizer will tokenize complete massive content and save as tokenized massive content. And now we have a vocabulary file with 30,000 tokens numbers. Tokenizer would use a vocabulary file to uh, transform massive content, textual massive content, translate in numbers and save that numbers. It is tokenized massive content. It is only numbers. And now coming to play real machine learning software. For a machine learning software, we need only tokenized massive content. All other remove from Steam, disconnect. Tokenized massive content will would be connected to machine learning, and machine learning see only numbers, see massive content, textual, see as massive numbers, and use it. OpenAI install machine learning. Machine learning is neural networks and dataset tokens vectors. It is machine learning. Tokenized massive content is here only during train, only during machine learning process. When process finished, in neural networks, we will have a trillion numbers like you see on the screen, trillion. For every token can be, for sum of token can be billion of them, but for every token more than million. Weights. Neural networks is a knowledge. It calculates statistic of every token versus every token. Uh, inside of context, what coming behind the token, what is in front of token, and a lot of example sentence in tokenized massive content. And the result of that is a trillion parameters or weights. How weights is every token in neural networks. Neural networks is divided in 1536 context, what we call layers of, and that 1560 36 content in every of that layers, in every of that content. Neural networks learn tokens versus tokens, interaction between tokens, position of tokens, weights of tokens in that section. For example, if tokens tomatoes or potato would be analyzed by neural networks in section agriculture, it would have parameters very, very high. Weight would very high because tomatoes and potatoes is very often in context agriculture. But for example, engine or something else, not so weight. And that parameters said a lot about position of token and weight of token in some section, and that statistics about every token in every contest produce numbers for vectors. Every token in dataset is presented by number, ID number. Text of token is in vocabulary file, and it is not important here. Tokens like number in that data set, every tokens will have embedded vectors. One token, one vectors. 30,000 token, 30,000 vectors. Every vectors, there is a 1536 number. You see connection between context layers with the number of 1536. And every vectors have 1536 numbers, like you see example on the screen. Oh, between it is decimal numbers, like parameters. It is decimal, also decimal from 1 plus 1 to minus 1. And that data set tokens vectors and that neural networks, when process of machine learning finish, stay only like locked large language model, and don't need tokenized massive content. We have only neural networks and data set full of number, only number. And it is locked machine language for that version of large language model, for example, GPT. Locked static machine learning, better say large language model, GPT, waiting for prompt. And now coming prompt. It is same situation when coming massive content. Instead of massive content, we have a prompt. And we need vocabulary file, and we need tokenizer, and we need tokenized massive content. But in tokenized massive content will not be massive content, but tokenized, not massive content, but prompt, only prompt, tokenized prompt. And after that, all the same. Tokenized would be disconnected, vocabulary file disconnected, prompt disconnected, and the machine learning, LLM, better say, need only tokenized prompt. And that tokenized prompt is enter in dataset in the neural networks. Tokenized prompt, it is only numbers, go in neural networks and data set tokens vectors. We at first go tokens vectors because that token have token ID token go in dataset tokens vectors, and that every token there is vectors, and with that vectors go to neural networks, because vectors there is a 1536 numbers what correspond with parameters and that vectors of token go in neural networks would go through all layers, and from statistic we have a likely probability position of tokens in answer in generative content, and we have a generative content on the output. Input is prompt, you see what happened, and output is generative content. And for that generative content, we need again a tokenizer, but it is contrary. Tokenizer must numbers, tokens in numbers. Generative content is only numbers, token, but in numbers. And the tokenizer, now we need a third time tokenizer that by vocabulary file that numbers translate in words, and we see generative content in words. Now we have a generative content output. Input was prompt, output was generative content, but in a number. Tokens are in a number. And again, we need tokenizer that contrary translate numbers in token, in textual token. Here is output, generative content in numbers. I'm only flip this arrow. Now we have output. Tokenized massive content can be output also, but it is massive content. It is reserved for machine learning. But tokenized output, and I see when we connect by OpenAI key, connect LLM to our application, we pay a number of token of response. Every response, there is a number of token, and we pay by token. And this version of LLM GPT version 5, there is a big saving in output token. I see today, okay, never mind. And of course, it is excellent because we have a cheaper, we have to pay less for same response. Okay, from neural networks and data set tokens vectors, we have output response. And of course, for that we need tokenizer to translate numbers in textual tokens, and it is for months. You see, AI produce, there is all what need to produce textual, generate textual content, and then the image and voice, etc. But here I spoke about textual. For men, for people, and for machine learning, for software, for machine learning, machine learning need only numbers, I hope you enjoyed this presentation. But how I learn with LLM, ChatGPT, I learned that I said my thinking, how I think it function. And I'm very, very successful in that response of AI is yes, you are correct. So I recommend you that you, on the fundament of this presentation, of this my explanation, that you communicate with ChatGPT, for example, why AI, LLM, don't use 27 letters, ABC letters from English language, maybe 27, 30. Why don't use letters? Why don't use letters instead of 30,000 words, complete words? You ask, but you don't ask. You at first thinking. I help you here. I at first, when I ask myself that, I thinking like letters. There is a lot of combination, and that combination is very, very hard because it is in infinitive combination with letters. But after discussion with AI, I see that I am right, because parameters for every letters, we need a trillion of parameters for every letter. And look at now, when the word tomatoes, it is token. Every word is token, can be subword, but for an example, tomato. When tomatoes coming in neural networks, and section by section, and for neural networks, it is number we see. In neural networks, there is nothing about understanding, meaning, etc. But neural networks produce knowledge, produce meaning. How? Tomatoes coming in neural networks, number. Neural networks in agronomy context, it is dimension in vector. It would be dimension in vectors. One dimension 1536, 1536. The tomatoes in agriculture, in massive content in agriculture, would be very, very often, and that often is tomatoes in agriculture is a reason that parameters is weighting is numbers is greater. In metallurgy, tomatoes is less less numbers, and that greater numbers and less numbers uh, inspire authors call it weight. And if tomatoes have bigger number, bigger vectors dimension in context agriculture than some other word, it gives meanings. It gives meanings. But if letter A, E, for example, in many words there is a double E, deep, deep, etc. A lot of letters E means nothing, but a lot of words, some word in some section have a is very big weight, because often spoken about. There is a lot of the tomatoes in section agriculture, and neural networks count every token count. How many token? It is statistic, all about statistic. How many this token? How many this token? How many this token? And about that, how many what tokens is in front of that? What tokens is behind it? And it construct meaning and grammar also. Artificial intelligence cannot learn grammar like we. My first association was, okay, it is no problem, artificial learning grammar and look at in grammar, write text. But no, grammar, artificial intelligence cannot learn from grammar, because artificial don't understand word, don't understand meaning, subject, verb, adjective, etc. Artificial intelligence cannot differentiate it. And we look at artificial working with numbers, And because of that, letters can be token, and but 30,000 token, and there is some connection. I also discuss and experiment. Does LLM give same response on same prompt? Not. LLM begin learning from people, from feedback, giving two different response, but it is same, but different use different word. And also is very interesting is what about different language, and artificial intelligence, massive content is multilingual. It means multilingual and don't touch from people. Artificial intelligence agents go through network and take content from social network, from forums, from books, take content like that and take Chinese, Philippines, German, what vocabulary, what text finding, and all that go in massive content, in massive content. And the same process is on the multilingual content. Okay, you try a deeper talk with the LLM about that if you interested. But for now, we see that artificial intelligence with only with numbers give us a very meaningful content and very meaningful, uh, very, very useful in learning, in coding, etc. Coding also, LLM don't learn grammar of coding language. No, and don't understand meaning. In same kind, in same way, like learning massive text, in same way learning programming language. Okay, I like to say you how I learning, how I talking, how I learning from artificial intelligence. Because when you only ask a question and have not your thinking but ask question, uh, response is not good. Response is very, very very not good, not better say not final. On that response, you must again thinking about that, and yes, you have new idea. Response give you new idea for new question, and the response for new question, but and in every phase of that, you can stop and say, okay, this is a very, very long discussion. I thinking myself a little about that. It means I will prepare better for that. And that preparing means that, okay, I now not ask, but I said what I think, what I think. And you will see it will be very, 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 very near, very near to correct, to correct. Uh, how number give all that? How can a number give all that? But can, because there is a lot of number. It is trillion and trillion numbers. It is billion and numbers about one token. One token in some context, maybe there is a 100 millions parameter would spoke, would give relation. Some numbers it's about relation with other token, and dimension number in vectors of other token also said a lot of about every of token, position, location of token, and a lot of numbers is very, very powerful and very, very, very interesting. Uh, you cannot work with the LLM without to connect by buying or in trial a generative AI key, open AI key or Gemini from Google generative AI. You cannot work without this knowledge, without this fundamental knowledge, without knowledge about this in my video. And because, for example, semantic searching, what I now learn, what I now coding, artificial coding with the OpenAI key, semantic searching is search search article, for example, what is have something together in some context. For example, you search for winter jacket, and you have only for winter jacket or summer suit, etc. And you will see on the screen. You can create it. You can understand. All would be created LLM, but LLM cannot create it without your guidance. You must guide it, and you must understand that number, how it function, and this process in embedded model, in embedded model. How prompt go to numbers, and that numbers, token numbers in numbers, go somewhere else, and when you must again use API to have instead of tokens to have a text, because only model can modern with the tokenizer can create textual response, etc., etc. I hope that this my video, it is third part, is useful for you. If you know somebody that need a video like that, tell them about that. Subscribe, like. Thank you. Your engagement is your comment is very important for me and for other who watching this video. Thank you for watching this video.